wider so I can see it better. Yes. Okay, and then go up. Okay, log mass is off. So chromatogram peak width is 3. That's good. That is the full width at half maximum. It's different from there. There is like the full width at the bottom.
At the base. Yeah.
Yes, here is at half maximum. Method duration. That's good. Customized tolerance. So let's click the inclusion list. Yes, we can see more options. So the default setting is 10 ppm. So here you have a mass. Anything between 10 ppm will be triggered. So basically you have a mass tolerance. Because they won't find the exact when you open it.
Yeah.
Yeah, and then they have a 10 ppm. Good. Now we can do polarity. Let's go down. That's the bottom, right? Then,
Yeah, that's the bottom.
Yeah, and this.
Oh, I didn't click anything though.
That's good. That's you are using the default setting.
Okay.
So I'm gonna grab the ES.
Okay. So now you are still doing polarity switching, and then here I'm going to enable the DDMS2. I find all the other options. You have to choose advanced. Then you have.
We're using confirmation.
Yeah, that's what I need. I was wondering where are they going.
How did it?
You go up in the properties of the method.
Yes, let's go up. Yes, advanced.
It said standard before.
Yes, standard they all gone. Yes, and then advanced they bring back those parameters. Yes.
So
it's,
DDMS2 is discovery. It's
So-
we're confirming.
So if you don't have the inclusion list, and then those are high concentrated, right? Then we can do discovery.
It's not that high concentrated. What's the concentration in the AI?
So it doesn't matter, depends on the background.
Something will be high enough in there.
Yeah, let's do discovery. And we can do 2 injections. One is targeted confirmation, the other one is discovery. You see which one you like. So right now, let's do like discovery. And the
Yeah.
ear source CID is off.
Oops.
Ear
So
source.
which means in future for us, like go over there, CID should also be off.
Yes, you don't need the ear source CID. It's for like you
You don't
see
need-
huge
you don't
amount
need
of
in-source.
solvent IDAX ions. You
Yeah,
turn
so
it
we
off.
don't need that.
Yeah, resolution 70K is good. Yes, for 70K resolution, it will take 256 milliseconds for one scan, but the polarity switching it take longer.
But if it's 17, how long does it take for that one?
64 milliseconds.
So
But
it's like a
I
twice.
recommend is 70K.
Okay. Oops.
Let's go here. I recommend the 70K, but one polarity, not polarity switching. And the scan range is 1, you can do several. So maximum scan range is X to 15X for your first mass. It's like 100 to 1500. That's the maximum you can set up.
What's the scan? You said 1, right?
Yes, you can do several scan range. You can do several scan range, but right now make it simple. We only do one. Then that is your scan range. That is the
So our
AGC
scan
target.
range don't need to go up to 815. We can just do like a 615. I checked all the AMP parts. It's
Craig had checked it before and chose that.
No, we don't have that like high. Just
But maybe something he wanted to add would go up
no,
to
this
there?
time it doesn't matter. We just
Yeah.
do 650. Give us like more
No,
data.
no. That doesn't relate it to anything. Like 850, 350, you all get the same data points.
Oh,
The data points is related
okay.
to the Orbitrap scan time, not related to the mass range you set up.
oh,
Yeah, so that doesn't matter.
oh.
Yes.
Just
Just follow the 15x rules. The maximum you can set up is the first to the 15x of the first mass. For example, 100 to 1500.
Or 50 to
50 to
15
750.
to 750?
Yes.
this one. What's the? You said.
60 to 850.
What's the difference you said there?
So I said it's like the maximum mass range is 15x. It's like from 100 to 1500. If you
Okay.
start from 60 multiply 15.
Oh, so the range is smaller
Yes.
than how?
If it's smaller than that, then that's fine. AGC target is like how many ions allowed in the OB trap. So 1 e to the 6 is good. It's a starting point. And if you need to increase the sensitivity, you can change it to 3 e to the 6. There is a chance you get the OB trap overcrowded. Then the mass shifted. So you can try 3 to the 6, you still get good data, then you can use it. But 1 e to the 6 is safe.
Or
Okay.
we go with a safe way.
Yeah, later you can change it. Maximum ion injection, IT. That is ion injection time. It's like the C-trap, open its gate, allow the ions to fill into it to reach the AGC target. You can imagine one situation, there is no ion, nothing is there. Then the C-trap won't open its gate forever. So you set up a maximum waiting time for the C-trap. Then you can do auto. The auto is it will automatically calculate it based on the OB trap scan time. For example, the OB trap scan time is based on the resolution. For 70K resolution, yes, it will do 256 milliseconds. Then it will, if you do auto, the C-trap will open for about 200 milliseconds. So the C-trap is ready for the OB trap. The C-trap collecting ions, then get ready for the OB trap. Microscan is like you average the spectrum. Before you have 6 points, and then you every 2 you average it. If you change it to 2, then you have only 3 data points. So 1 is good. Then data is type profile. Profile is a peak. For the centroid is a stick, so it doesn't matter which one you choose. Profile is good. DDMS2, you only need to see the fragments present. Lowest resolution is enough. Most likely is enough because you just need for confirmation. And it takes 64 milliseconds. That's allowed. Then isolation window, we can change it to 1. I don't like to change it to, yes, that's to 1. Oh, that's too much. Let's change it to 1, yes. Okay. Isolation offset. This one is for like a protein or peptide research. For
So we
example,
don't need that.
yeah, you don't need it. For example, your isolation window is 4 and 2 is in the middle. If you do offset for 2, then you shift the center, then you get more isotope included. That's related to the protein or peptide analysis. For the protein, they always have an isotope distribution. They want to get all of them included, so they shift the offset. But for small molecules, no need.
So we go to NC.
Yeah, this one we do NCE, we do step, like 20, 30, 20, 40, 60. If you do discovery, you don't know. Yes,
20.
yes. But I still need the formula. Later we can find it, like what's inside of it.
Yeah, we need it. We have found it from our old database.
Okay, that's fine. And then first fixed mass, we don't need it. Default charge state is 1, that's good. Here is the AGC target. We change it to 1 e to the 5. Because now for DDMS2, you isolate the ion in 1 Dalton window. So there are not much ions as your full scan. Your full scan, the window is quite wide. Then your AGC target is 1 e to the 6. So here, you are only do a 1 Dalton window isolation. So you don't need to set up a super high AGC target. Then the C-trap waiting time will be long. So you want to have a shorter cycle time, so make it a little bit smaller. Loop count. So that's after after full scan, how many DDMS2s you need? Like after
How
2
do I
scan,
know?
then you set up the loop count. 1 is 1 DDMS2. If 3, it will be 3 DDMS2.
How do I know how many?
How many? That depends on your purpose. If you do unknown screen, you may do 3 to 5 is recommended. For targeted quantitation, if your compound is co-eluting, lot of them co-eluting, you may still do 3 to 5. But if your compound not co-eluting, you only have 1 standard, so 1 is enough, right?
So this is DDMS is like the product line or
Yeah, product ion, you will get the MS2 spectrum.
So 3.
You said 3 to 5, right?
Yes, 3 is good because you are doing polarity switching. There are not enough time already.
Yeah, so we got 3.
Yeah, okay. Again, each takes 64 milliseconds. So that is the minimum AGC target. So you require how many ions are there? Like you set up an intensity threshold for this ion to be triggered. For example, in the full scan, they find this ion, and then they require the intensity to above certain level, then it can be triggered. I can tell you the recommended is 1e to the 4th, like a minimum ADC target. But the minimum you can set up is 2e to the 3.
What's the 2 is?
Yes. You can, the minimum you can set up is 2e to the 3. We can keep it right now. Later you can change it.
Twice you said it's already.
Yeah. The apex trigger is there is a peak. You ask where it triggered. It's on the apex or it's not on the apex. It doesn't matter for Orbitrap instrument. So this one is important. Dynamic exclusion, we turn it on. Like let's make it like the same as your peak width. Then this compound will be only triggered once. Dynamic exclusion is like you have a compound A is triggered. Then dynamic exclusion for 6 seconds. In that 6 seconds, it won't be triggered.
So this peak wise is like based on minutes or seconds. You said this one is
Second.
So it should be 6 here.
No, let's do 3. It's also fine.
3?
Yeah.
I think-
Why? Because your peak width is 6 seconds. Then every 3 seconds it will be triggered once. So it will be triggered twice when it got eluted. Once it's triggered, the compound got eluted, and then the other one it will be triggered around the apex. So it will be triggered twice if you do 6 seconds. And charge, you can exclude the charge state. So for small molecules research, you don't need to worry about it. For protein or peptides, they have so many charge states, then you can uncheck it. Exclude isotope. So like only the monoisotopic ion will be excluded. All the other will be triggered. All the others will be excluded. So you don't want to trigger the same thing over and over again. You give others opportunity for discovery. And then profile. We can do centroid. You have a smaller data size for MS2 data. Okay, let's save as file. And then save as. We say it discovery. We give it a name as discovery. Yes. Okay. And then save. Yes. Okay. And now we change it to confirmation. Yes. Okay. So now only the compound in your inclusion list will be triggered. Nothing else will get triggered. Then it's like only this compound will be triggered. And then we click done.
Do you want to add some more?
Let's try one first to make it work. Then let's see what is the difference. You have some option that is gone. You can see there is no dynamic, there is dynamic exclusion. Okay, so everything looks the same. So the idea is confirmation, only this one will be triggered. Discovery, like everything, like the most top abundant one will be triggered.
Interesting.
Yeah, you don't have a top N. We can change the loop count to 1, so only that would be fine. If you don't have so many compounds got triggered, then we can save it. Save as, like confirmation. Then we can run a test.
We are still working on method.
I suggest you mix the standard together. Do you mind?
With a mixture step.
So it contains this compound, right?
No.
No. I can mix it.
That's fine. We don't need to mix it. That's fine. We don't need to mix it. Let's just use it. Yeah. No worry. Let's say confirmation. Okay. Now we can use a quick acquire to acquire our data. Yes. Then we can call it confirmation first. Okay. And the one is at 6:48. How about the other one? The other one have a mixture.
That one doesn't include that compound.
That doesn't matter.
49.
49, okay. And then injection volume.
That's 210. It's like really low concentration. It's
The syringe doesn't do that.
We always do 5 on the orvicapsine. I don't know why, but it should be sensitive enough.
Okay. Let's include our method.
D.
Yeah, confirmation. The other one is discovery. Yes, and then we can highlight those. Acquire. Turn it on. Okay.
Ready?
What are you looking for?
I'm looking for this milk size, so it's 20 microliter. We can definitely do better, so it's okay.
Oh, okay. That's fine. Let's see. If we couldn't see it, then we inject more. Okay.
I think that loop size is one of the like something decided we
Yeah.
like how much.
Also, the color